Hi, welcome to KSR Datavizon Snowflake program. Today, in this video, we are going to discuss about Snowflake Data Cloud. The elements we are going to discuss are shared disk architecture, shared nothing architecture, Snowflake architecture layers. Now we're going to discuss about shared disk architecture. So, this shared disk architecture in the current world of software or any DBs we're talking about. So there are majorly two kinds of architectures is being used across a different DBs. Majorly it's a shared disk architecture and another was a shared nothing architecture. Okay. So this architectures, we will see what is this architectures, how it will be useful, and what is the difference between these architectures. So let's discuss about shared disk architecture. As we see on the left side diagram, so shared disk architecture is nothing but when a person or some client has been pushed a query, how the underlying DB architecture will get reacted. Right? So once we get a query being filed on your console or from any client, so how the underlying architecture will take that request and fetch the data for the client and show it back to the client. So as soon as the query is being filed on a DB, so what happens is it goes and it triggers this clusters in a shared disk architecture. So here if you can see, each cluster will have its own CPU and memory. CPU is for the processing and memory is for all storing the metadata and how the clusters are working and heartbeat of the clusters, and everything will be taken care by the memory. But the main thing with the shared disk is it's a common shared disk storage for all the cluster nodes are available in the architecture. Okay, that means all the cluster nodes, whatever is there in this particular architecture, will consume a data from a single storage disk. Okay, that means if whenever the query comes in, the query will get splitted into all these ones, and this will start reading data, scanning a data from this table. Okay, that when let's see the first statement here. Yeah, used in a traditional databases that I said, like all the on-premises we have used, mostly it will be a shared disk architecture. This was the traditional one and which is running from a very long time. And shared disk architecture has a one storage layer accessible by all cluster nodes. So as I said, how many clusters you will be having here, everything will be accessing a single data storage. Okay, so here the second point says multiple cluster nodes having CPU and memory with no disk storage. That means if you see a single cluster, every cluster it have its own CPU and memory, but it will be not having any data storage to particular clusters. Okay, so all the clusters will start using the same data storage, disk storage we can call it. So here with no storage for themselves, communicate with the central storage layer to get the data and process it. Like this is the central storage layer, it will access from it and it will process it to the client back. Okay, any machine can read or write any portion of the data into central data storage. So what it means, when a customer write some data, example saying that we have written an insert statement, right, insert into employee table. Okay, so that means any of this cluster can take that request and it will go into this disk storage and it will lock that particular table. That means it will lock this employee table and it will start writing the data of that employee table. Or else if you want to insert if you are doing an update, okay, updating some 1 billion records in a table, so what that will do, any of this cluster will take the request and it will log that particular table and it will update that 1 billion records. Okay, if the table is get logged, that means if any other query is being requested at the same time and any other cluster has consumed that query, when the table is already logged, this particular cluster will wait for that information, this table get unlocked, then only it will happen. So that means there is a lot of issues with the concurrencies. So when you want to run the multiple queries at the same time, so there will be some kind of locking mechanism happens. So this architecture has some disadvantages and some cons as well. right? So here we can see scalability and performance are limitations. So just we discussed the performance when the second query comes up for the table. So it has to wait for that resources to be available and the table is free to access the data. That means we are degrading the performance here, providing the results back to the customer, right? And scalability. So here the scalability, when we say if you can scale, you can add a one more cluster here. Okay, so how many clusters you're going to add, right? That much pressure you're going to put it on the disk storage. So scalability is also very high. So if you are going to increase over here, you have to increase the disk storage also, else these three existing layers also will get impacted. Okay, so this is one type of shared disk architecture. Okay, so we'll discuss about next one, shared nothing architecture. So in this shared nothing architecture, you can see the difference between the shared nothing architecture and the shared architecture is the memory, the storage and CPU. Okay, is all going to be a one club here. Okay, we have seen in previous slide only one disk storage is there and all the cluster nodes are accessing a single disk storage. But here in a shared nothing architecture, every cluster will have its associated data storage also, disk storage as well. So that means, so it individually works and this individually works and this individually works. Whenever the query hits, what happens is it will just go take the query and the particular cluster will get that query as an input and it will check whether the data is available in the disk and produce back the results to the client. Okay, that means if there is 100 queries comes up, that means this queries different clusters, it works independently, it can takes the queries each one at a time and it parallelly process. This is nothing but a parallel processing in this massively parallel processing world. So shared nothing is something which brought up a parallel processing, excelling the DB results. How can we fetch as early as possible from the disk storages? Okay, let's go into the comments. Okay. Shared nothing architecture has distributed cluster nodes along with the disk storage, CPU and memory. We just discussed it will have when you take this particular slice, it will have a CPU, memory and disk storage. Okay. The next statement says advantage here is that the data can be partitioned and stored across these clusters nodes as each cluster node has its own disk storage. That means when you have an employee ID, okay, so what happens is in this employee table, okay, so this employee is if we have whole India, particular government sector, whole in India, how many employees from different locations are there, everything will be have you have loaded into a tables or a table. Okay, so how it will get stored in a backend is, so it will get the data partition. That means all the Hyderabad, all the Delhi or all the Uttar Pradesh, everything will go into a different partitions. The data will get partitioned. So whenever the customer queries, but sends a query saying that I need a Delhi customer record, so the metadata will identify as soon as possible the query is fired and it will send the request to the first cluster as this having a Delhi information. It as soon as it identifies the query and it fetches back the data and provide to the client. That means it is parallelly processed and it provides a quick results for the customers. Okay, so that is a major advantage having the shared nothing architecture. Okay, it's very important to understand the two architectures. So the major difference is in shared disk is nothing but that one disk will be there and shared across a different clusters. Shared nothing architecture, there will be no communications between there will be a slight communication bridge will get formed. It's only for the resource sharing, but this all slices will work independently. That means it will not share any kind of resources with it. So what it happens is just a bridge between the nodes. So this is for the metadata informations. Apart from that, all the compute resources or the CPU, memory, everything, it individually works. Okay, that's what this statement says. The last statement says each node in the cluster stores a portion of entire data set locally, which enables a massive parallel processing. Like I have just mentioned an example. So if you are taking employees in whole country India, so the different states information will get partitioned into different DBs. So whenever the query hits, the metadata will read that query. Based on that, it will send the request to the corresponding data disk or a cluster node to fetch the results. Okay, in that way, we can able to produce a massive parallel processing and fetch the results as early as possible than compared to share nothing. Okay, so these are the two major difference we can see between a shared disk architecture and shared nothing architecture. This slide, the reason we have discussed why shared disk and shared nothing architecture is we want to highlight that Snowflake is the one of the database or cloud data warehouse is using both shared disk and shared nothing architecture. That's called as in a hybrid model. Yeah. So this, so some every architecture have its pros and cons. Okay. Some, if you example, if you take a shared disk where it is a scalability is tough, when if you consider shared nothing, scalability is good, performance is good, and resource utilization is something will get little complicated in shared nothing, that will be good at a shared disk. So as this is a combination of both shared disk and shared nothing architecture, right, so it uses the both pros. That's the reason we call it as a hybrid, and it fetches all the benefits of the both architectures. That's where Snowflake architecture provides a lot of flexibility, providing the results very quicker than compared to the other DBs. Okay, let's go to this other two statements what we have mentioned here, right? This model brings the best two architectures in which it uses a central data repository accessible from all compute nodes and processing queries. Okay, that means whatever the data, underlying data is being stored in a Snowflake. So all the compute resources we discussed, there will be a warehouses in a Snowflake. So all these compute resources will start accessing this data, right? So this is nothing but a shared disk where we can produce a massive parallel processing. Okay, and this is where each node in the cluster works on parts of computational task in parallel. That means this all warehouses, right, every warehouses will work in a parallel way. Okay, it will not get any resource will be shared or make some other resource to wait for something to be available for it. So as is interdependently works, each compute resources will access this data. Okay, this data will be a micro partitions or clustering, everything will happen. So this compute resources, this gives an additional benefit when it reads partitionings, right? So it easily identify what the exactly the customer is looking for. Okay, so that's the major benefit of having both shared disk and shared nothing architecture in a Snowflake architecture. Okay, so here we can see a one example we mentioned. So with this hybrid shared data model, Snowflake has the data management simplicity of the shared disk architecture with the benefits of having the shared nothing architecture. So as I said, this is the shared disk and this is the shared nothing. So it's a combination of both. So what it means is, so it gets the management simple. That means easy to maintain. Okay, and the massive parallel processing is happening as the individual computes are accessing the data, underlying data, right? So this gives a lot of boost up for the Snowflake architecture. Let's look at the architecture layers now. So if we see, this is the three architecture layers we have it in a Snowflake. Majorly we have is cloud services, the first layer, and second layer is a compute or warehouses we can call, and last layer is a storage layer. Okay, these are the three major layers we have in a Snowflake. Okay, let's see first, when we observe this Snowflake, yeah, when you observe the first layer, right, so you can see authentication and access control. So authentication and access control is nothing but, so when you try to access something or when you want to, an account has been created, so for every account there is a roles, there is a logins, or a multi-factor login or a single sign-on logins. All these authentications can be set up on a Snowflake. Next one is access control. So when we're talking about access control, this is a major one we need to always need to know what is access controls means. So access control example, you take, there is a customer, you are running a health business. Okay, there is a patient's information, so you cannot share this patient information with everyone. That means you have to keep it very secret. In that cases, what will happen is, whatever are the tables which you are having the data related to health information, okay, our PII information, personal identification information, our PCA information, personal card information, our HIPPA information, health information, all this stuff you can't share with everyone. So how can you put that access on a particular tables or a particular roles? That means a granular level of access also you can provide in a Snowflake by creating a roles, or by doing a data masking, or providing the access to only certain tables or views. Okay, so this layer explains that. So next thing is infrastructure management. So in our previous sections also we have discussed, infra is being totally handled by a Snowflake team. There is no hardware or software to install or manage, or any upgradations or tuning in that case, or taking downtime. So everything will be taken care by the Snowflake team. So this is something called as a freedom from DBAs. So in current world we will be depending on a DBAs. Now we don't require this DBAs, right? So next one is an optimization. So optimizer is nothing but anything the data gets loaded into your storage. So this optimizer will compress the data. It keeps compressing and it provides more storage or more space to load more data, right? Transaction manager. So that means if any transactions or any queries if you have executed, so all that metadata will get stored. So in our previous sections we have discussed, every query will get a QID or a time travel or a failover. So all this kind of information will get stored in a metadata or in an admin information. That means how many tables you have, how many people users are there, how many roles are there, right? All this information you can find it in an information table that you get it from a metadata. Security we discussed. Snowflake follows a different levels of securities, that is like a SOC type 1, SOC type 2. Okay, all this PII information, GDPR rules, HIPAA rules, so it follows at different security levels. In a recent survey run by a Snowflake team, okay, they got a very good NPS, that means net promoter score, from the companies which are adopted this Snowflake. They got a 90% of satisfaction rate from the all the outside customers, that Snowflake is providing a very good security and data encryption or decryptions at rest and at moment. That means when the data is stored at a table, or when we try to share the data with someone at the runtime also, the data is very secure. Okay, so this is the cloud services we could see. Okay, and let's read about what we have written, the statements we have at that side, right? So built-in security, so it will be taken care by the Snowflake team. Data protection and retention, availability and more. That means the data rekeying, encryption or rest at motion. Retention, how many days you want to keep the data, that retention you can keep. Availability, we have every time and any time the data is available here. There is no downtime in the Snowflake. And there are more other feasibilities or flexibilities we have in the cloud services. Right. Next, we will discuss about second layer, that's called as a warehouse or computes. Right. So in this computes, we have a compute engines. So we discussed compute engines just now in the previous slide, how these compute engines will help. So whenever the client requests a query or something, so this compute engines will get activated and it will start communicating with the data storage, and it executes, it runs and fetches the data from the data storage, right? This compute engines, we call it as a warehouses. Okay, this warehouses you can scale up or scale down. Okay, so what is scale up and scale down is, if you want to get a quicker results, or if you want to run in numerous lines of a query, or you want to read a large number of volume, so in that case you can scale up the warehouses. The warehouses are sized between XS to 4XL. Okay, these are all the t-shirt sizes. That means 1 to 128 compute engines can be triggered in a milliseconds. Okay, so that means you fired a query, you want to fetch a data of 3 billion records you need to fetch, and you selected XS, and it is, you seen that it is taking a little more time, so you understand this query might need a little more computes, then you choose something called as a medium, right? So medium, when you compare with XS, it will be a many times better than the result speed you got it with that means you can scale up or you can scale down. That means what happened is you find out there is a less important queries needs to be executed and give the preference to the important KPIs. In that case, you can choose the warehouses for that particular queries to have a XS or X. That means it won't consume many warehouses, and it provides a more resources for wherever you have assigned. Okay. So to understand here, this warehouse is also very important to understand, and it's the concept majorly in stored procs or while you're trying to load a bulk data, everything everywhere, right? This concept is must. Okay. So based on the warehouse size you select, the cost is associated to that. That means if you example, I can say if you have selected excess, that means 100 rupees per 60 minutes. If you use for Excel, that might be 1,000 rupees for 60 minutes. Okay. So in Snowflake, how the cost will be calculated is cost is equals to storage plus compute. That means the compute plus storage. Okay. This is the cost they will calculate here. How much time you have executed your computing, just like that. That's the layer 2, and layer 3 is storage. So we can this storage. So this storage can be lies on any cloud services which are providing here. That means either Google or Microsoft Azure or AWS. While you creating your account, you have to select one out of this. Okay. So based on the thing you have selected, right, your data will get resided there. The storage will be cost the how much information you're going to store there, and how much tables or how much GB or TB data you're going. Based on that, how much time you're going to save, put the data over the storage, right? So all this information, the cost will be calculated based on the retention of the data you're maintaining there and the amount of the data you're maintaining there. Okay, let's go through the statements we have written against to the service layers, right? So you can see here for the metadata also, automatic metadata management and offloading, results catchy. So results catchy is nothing but when you run the same query again, so it will never go to the storage, right? It will check if there is previously you executed that query and fetch the results from the caching. So it's a faster results you get it, right? Next one is boost performance for repeated queries. Like I said, if you repeated the query, it will never go to the storage. It fetches the data from metadata query ID and it shows the data to the customer, right? Next one is dynamically add or size the virtual warehouses. As I said, you can change the scale up or scale down automatically by setting few configurations in while you're running it. Okay. And last one is automatically scale up, scale out or up to 10x virtual houses. That means every time you 10 times greater than if you want to scale it, you can scale it. So by using the same scale up and scale down mechanism. Right? And coming to this, right? Compute and storage scale independently. So what means? That means you can in general world or in an on-premise world, what happens is if you are buying something or if you are buying some hardware, right? So what will happen? You need a 1 TB of hardware or 1 TB of a space unit. Okay, but when you go to the company, they says that we will sell only 20 TB. All right. In that case, what happens is the 19 TB you are adopted is a simply waste of money, right? So but in a Snowflake, when it comes, you can choose only for the 1 TB, and whatever the amount you are using, you pay only for that. That's nothing but a pay as you go, that pay only for your consumption, right? And if you want to increase this one, you no need to increase this one, right? So irrespective of if you want to increase this area, you don't want to increase this area, independently you can increase any of this one. So that means that's the point you're saying, compute and storage can scale independently. There is no hard dependency between you increase the compute, you increase the storage. You don't need to do that way. Okay. Size when needed. So whenever you needed warehouse size, you can increase, as I said, scale up or down. Okay. 120 1280x scaling times. As I said, 128 times the compute resources can be increased in a milliseconds. That's what the scaling range has been provided here. Okay. So this is how the Snowflake architecture is built on cloud area. Okay. I hope this video makes excel your little knowledge on a Snowflake.